Okay. Let's begin with 4-1. So 4-1, 4-2, 4-3 is our lesson for today. We're going to talk about basic concepts of probability, addition and multiplication rule, and then complements and conditional probability. So these are the three things that we're going to do today. Okay. So please read the key concept for a few seconds or maybe a minute. Okay, so we're going to talk about how to interpret probability values, which are expressed as values between 0 to 1. A small probability such as 0.0001 corresponds to an event that is rarely happening or occurring. Next are odds and how they are related to probabilities. Odds are commonly used in situations such as lottery and gambling. So we're going to mainly talk about the interpretation of probability as us. So I'm going to briefly go over this PowerPoint and then vocabularies that you need for probability. Event, simple event, and sample space. Again, another minute, please read, take a quick note, and then we'll go over that together. Okay, an event, one event, is any collection of results or outcomes of a procedure. So event of a baby boy or a baby girl. So that's one event, like baby girl, if that's our fate. Simple event is an outcome or an event that cannot be further broken down into a simpler components. So sometimes they can be broken into a simpler components and sometimes not. So basically simple events is when, so we're gonna go to the next one and you see their examples. Sample space is all the possibilities. Sample space means like if it's a baby boy or girl, so just for one birth, then boy, girl, as of one birth is the sample space because that's all the possibilities. Okay. In the following display, We use B to be for baby boy and G for baby girl. Okay. Look at this one. If you are in favor of, let's say, a baby girl or a baby boy, whatever, that's one thing. It's a simple event. Out of two options, your favor is girl. So that's a simple event because it cannot be broken down anymore. And then out of three birds, two boys and a girl could be BBG, means the first one be a boy, the second one boy, the third one girl. The first one boy, then girl, then boy, because there are three possibilities. Or the first one be girl and then the second children to be boys. Are all simple events. So each of them are simple events, but that's how they break down. And the entire sample space, please look at the sample space here. Sample space means all the possibilities of those three birds. If you are in favor of two boys and a girl, then the event is two boys and a girl, which that's just an event. You break them to simple events of two boys first and then a girl, one girl first and then two boys, or two boys and a girl in between. So that's your favor, which you broke down the event into simple events, but then all the possibilities called sample space. So three boys, two boys and a girl, two boys and a girl in between, boy and two girls, girl and two boys. So do you see all the possibilities? You need to come up with an algorithm to write them out. So for example, if you are writing the algorithm here, let me just make this a little bit larger. So if it's a boy, you would say, if the first one is boy and the second one is boy, and sorry, that should be a lowercase boy. So I want to show you how you write down all the sample space. The third one, now the third one can be a boy, or you can have B, I'm gonna just put it with no space so it's easier. Or you could say boy, boy, and the third one to be girl. So you're done with the cases that the first two are boys. Now let's say the case that the first two ones are girls. So you would say girl, girl, the third one could be a boy, girl, girl, the third one could be a girl. So that's four cases. Then you would say, what if I have a girl, then a boy, and then for the third option, I can have another boy, or I can have another girl. So it would be girl, boy, girl, so on and so forth. Then you go and say, what if the first one is, so far you had two boys in a row, two girls in a row. Then you would say, what if I have boy first, then girl, and then the third one could be a boy, or the third one could be a girl. So this seems to be all the possibilities. 1, 2, 3, 4, 5, 6, 7, 8. So, and then out of those, you would say, which one is my favorite? The event of two boys, the event of two boys and a girl. Then you go and see, oh, I have one here. This is 1, 2 boys and a girl. Then I have this as two boys and a girl, and this as two boys and a girl. So all three cases that was listed here. It's more of an algorithm of what's the sample space and what are my favors. Any questions so far? Okay. Let's just. Yep. So we talked about simple events is just one thing, but then the other event where it was event, but you broke it down to simple events. If it's a two girls followed by a boy, is a simple event. But if I say three birth, two girl and a boy, then you need to have three cases. So it's not simple event.
Hey, Professor, can you explain that again? The simple events with two girls followed by a boy.
So here, do you see they were specific? They say with three birds, two girls followed by a boy. So that's a simple event. You cannot break it like saying the only possible case is girl, girl, boy, right? Because it says two girls followed by a boy. But if that was like the previous one that says two boys and a girl, they could be two boys and a girl, boy, girl and boy, could be girl, boy, boy. So it's not only one case out of all of them. So
Okay.
if I have like two boy or two girls followed by a boy, then that would be only 1 out of 8 possibilities. But if I say two boys and a girl, then it would be 3 things out of 8. So does that make sense?
Yeah, that makes sense. Thank you.
A simple event is just, you cannot really break it down to anything further. Another example is when rolling a single die, the outcome of 5 is a simple event. But the outcome of an even number is not simple event. Or the sample of odd numbers is not a simple event because you have possibilities. 1 is fine, like for, let's say for even numbers, 2 is fine, 4 is fine, 6 is fine. So yeah, by saying one event, you had 3 favor. But then with rolling a single die outcome be 5, that's simple event because that's the only favor that you're looking for. If that makes sense. Any question?
But when you roll in a single dice, you can get 1 through 6.
Yep. So those are the sample space.
So how's that? How can you only get one number?
Outcome of 5, this is event. So they say, what is the possibility of the event? Or they would say, what is the probability of the event that the outcome is 5?
Oh, okay.
Then you say out of 6 possibilities, as you said, 1, 2, 3, 4, 5, 6, my favor is 5, which is 1 out of all of them. So it's 1 out of 6. So basically you would say outcome of 5, how many 5s do I have in a die? Just 1 5, right? So if I was listing the sample space, so let me show you. If I was listing the sample space where I was it here? Where did that page? Here. Okay. So you would say the sample space. Do you see what I'm writing here? Could be these. Could be 1, could be 2, could be 3, could be 4, 5, and 6. What is my favor here? The favor is the event. Favor is 5. So what are your chances? Then I would say, what is the probability, which I show with P, of rolling 5? So we're gonna get to probability of that too. Probability would be your favor over total. So how many, or number of favors, number of possibility of favors, and number of total. So that's equal to, it's one favor out of, so number of favors, it's just one item out of 6 possibilities. So 1/6 is the probability, which you can always put it into your calculator and get the decimal and percentage. So that's 1 out of 6, which is point, if I write it to 3 decimal places, 0.167, which I write it as a percentage. I need to multiply it by 100. So it's 16.7%.
I'm done with these 2 groups.
Okay, what did I tell you after you're done? What should you do?
Monica, do you have questions?
Oh, sorry, no.
So 16.7% is the probability in percent. We normally write it as decimal, but always at most our probability is 1 and at least is 0. Probability is never is negative and never over 1. So we did one problem here. Does that make sense? Do you see how I had the event for the second one? I wrote the sample space, means all the possibilities. So number 5 is my favorite. That happens 1 out of 6 chances. So, okay. Another not simple event when there are 3 birds and 2 girls and a boy, because you can break it down to 3 possibilities. So it's an event. So you could say, what is the probability? So if I was writing probability of 2 girls and the boy. Then you would say we had the sample space. There were 8 items in the sample space, and 3 of them will give me 2 girls and a boy. So it's 3 out of 8, which again, you can find the decimal. So let's see. So simple event and sample space. Simple event, it's just the event is always what you favor on. Either it's simple or it's just an event. So in this case, it's not simple, but it's an event. And then it could be single, just saying 2 girls followed by a boy, which is just one single event, or just say 2 girls and a boy in total. So you have 3 items. Sample space is all your possibilities. So sample space means what are all my possibilities when I'm rolling a die? So basically, sample space is a procedure consists of all possible simple events. Everything that is possible in 3 birds. What could be the possibilities of 3 birds? Event, no matter if it's simple or not, is what is my favor. Okay. So now, P is for probability. A, B, C are just events, so we are just naming them. Okay. Just know that probability of event A means probability of that happening. What is the possibility that you're rolling 5 in a die? So A is the event, and then P is standing for probability. So probability of whatever. Okay. So I want you to look at this graph. Let me make it bigger. I give you a minute. Just look at this one. This side you have probability, and this is impossible, unlikely, chances of 50-50, likely, certain. So look at this one and see if that makes sense. Okay. So when you find the decimal, it should fall between 0 to 1. If the probability is 0, it's impossible. Rolling a die, what are the chances that you roll 7? Probability of rolling 7. Can you roll 7?
No.
No, so the probability of that is 0 because you have 0 out of 1, 2, 3, 4, 5, 6. None of them is 7, so it's 0 out of 6, which is 0. Okay. Unlikely means you have a low chance, 0.001, 0.1. 50-50 is when you have, let's say, boy and girl probability of birth of a boy is 50-50 chance. If it's a 50% boy, then the remaining, which is a girl, is a 50% as well. Likely and certain. So if that's 92% happening, the chance of, let's say the chance of raining today, according to the previous year, same time, June 23rd, it's 50, let's say, 92%. So it's likely that is happening today. So that's just an example. So with the high decimals or percentages, then it's more probable. And then certain is 100%. What is the probability that, let's say, oh, what is the probability that you flip a coin and it's, flip a coin once and it's either head or tail. So since you're saying either, it's going to be either one. So 2 out of 2. It's certain that either happens to be head or tail. Although I heard that it's a very low possibility that it's on the side that it's neither, but let's assume that it's either of the two. Or think of an example of something that is certain. Can you think of that and send it through chat? Can you think of something that is certain happening out of things that are probable? What are the chances, probability that sun rises tomorrow morning? So 100%. So things like 100% that I will have brown eyes today. So just something that is certain. Probability out of events that are possible. Okay.
Excuse me, Professor. I forgot what denotes mean.
Denotes?
Yeah, like for the notations for
Yes.
probability.
Yeah,
says
probability for notation of we denote P for probability. That means the notation for probability is P.
all right, for sure.
Chance, 100% chances that someone will be selected for president, as a president. That's right. Okay, so. Finding the probability that it's between, so always probability is a number between 0 to 1, between 0% to 100%. It could be 0 if impossible, 100% if it's certain, and anywhere in between them. So please write, I would say, please write this or take a note of this important thing. Okay, relative frequency. Relative frequency is approximation of probability. Same thing as we said, probability of an event is number of times that that event is possible over the total number of possibilities. So basically favor over total. Okay. Again, the classical approach would be the number again on our favor divided by the total, which they are pretty much the same thing. Okay, for the rounding, they say to 3 digits. I normally say how many digits when I'm asking you in the exam or quiz. So go to 3 decimal places if I didn't. Okay. Let's say, let's just look at the example of skydiving. Find the probability of dying when making a skydiving jump. In a recent year, there were about 3 million skydiving jumps and 21 of them resulted in deaths. So if you want to find the probability of a skydiving death, is the number partial that it's in the favor of the question, not our favor, of course, of those who've been dead. So that's partial over all of possibilities. So 21 over 3 million. So then you put it to your calculator. So put it in your calculator and see what you get. So use your calculator. 21 divided by 3 million. So do you see, maybe your calculator gives something like this too. 7 7e negative 6. So this means this is the same thing as the scientific notation of 7 times 10 to power negative 6. So that means take the go 6 places backward for the negative 6 power. So that means you start from after 7 and you go backward 6 places. So that would be 5 zeros. So that would be decimal, then 5 zeros, because this is to power negative 6, 5 zeros, and a 7. And that's the same thing you have here. So 7 times 10 to power negative 6 means imagine that this decimal is after 7. And then you take it and go backward 6 places. So when you go backward 6 places, you're gonna have 5 zeros and then you drop the dot there. So
Okay,
5
so
zeros and then a 7.
So when you say 7e, it's just basically you're going back 6 spots.
Exactly. You go 7 spots, including the 7 backward. Or you would say 5 spots of 0 and then 7. So that's exactly what it means to be e to power negative 6. It means 5 zeros before 7. If that was e to power negative 10, that means 9 zeros before 7. Okay. So just reading calculator is also important. And that's very unlikely to happen. Okay, texting and driving. So please read this one. So think about it, that what is the favor? Favor comes after the probability. Probability that she or he texted while driving during the previous 30 days. So that's the probability. And then total, find what would be the total of people that we are surveying. So number of those who texted over total will be the probability. So read this question and see if you can find the probability of she or he driving. $3,785 texted while driving. 4,720 did not. So the total number of people would be addition of these two. So that's the total. Our favor are those in this question, in this probability, is those who are texted. So on top, I put the number of favor, and then on the bottom, I put the total. So you add them first. So that's your total. And then favor would be drivers who texted while they're driving over the total. That's the number. Okay, 0.445 probability that if a high school driver is randomly selected, she or he will text while driving. Make sense?
So you add them first, and then you divide your favorite by your total, right?
Yeah, I want you to, instead of saying, oh, I add first and I divide, think about that you say favor over total. Favor are those who are texting, so we are fine with that. But then what are the total number of people we observed? So we observed those who texted and did not. So as we were surveying, so then the total would be, we need, in order to find a total, we need to add texted or not. Does that make sense? So I want you to have the comprehension of the question. On the bottom, I always need total. Sometimes total is given. Sometimes I need to find a total. In this case, you need to find a total because they didn't say how many people they surveyed in total. They said they surveyed this much, said they did not drive, this much said they did. So you need to find a total. Okay, let's just go to the next. Give me a second, please. about to fall. Our dog barks. Okay, let's go to the next question. So favor over total. Complement of an event that we also gonna see the probability of that in 4.3 today. Complement of an event is whatever is the event, what is exactly opposite of that? So what is, if I say event of texting while driving, what is the probability, what is the event of complement to that? Driving, not texting. So basically you always say complement to an event is the outcomes which the event does not occur. So completing that basically out of one. Let's say probable, I mean, if the event is rolling odds in a die, then rolling even numbers is the complement to that. So complement means exactly things that will not happen. Like what are the things that will not happen? Or they're opposite of each other. That makes the entire sample space complete. So for the skydiving, if I say find the probability that not diving when making a sky diving jump. So you say 20 of one of them will die, so the remaining will not die. So send me your numbers. Please respond to the chat. I want to see how many of you are following. What if 21 of them die out of 3 million? What is the number of those who will not die? What is, and then find the probability of that. Tell me how many people will not die, and then also tell me what is the probability of that. 21 will result in death. Find the probability of not dying. So exactly, so I'm receiving answers. Great job. So now find the probability, Mason, of excellent. Okay, awesome job. So you would say 3 million minus 21 is those who are not dying. And then out of 3 million, it's 0.999993. That's the probability. Which is,
How do we, I'm sorry, how do we find a probability again?
probability is partial over total. Your favor is not dying. If 21 dies, the remaining will not die. So that would be 3 million minus 21.
And you just divided the 3 million by the outcome.
Yeah, you divide that number by 3 million.
Okay.
In another word, so do you remember when we were doing this problem? When we were doing this problem, we found the probability of dying was 0.0000. We said 5 zeros and a 7. Complement is always 1. So if I was doing a 1 minus 0.000007, I would have get the same number. Do it to your calculator. So say 1 minus 0.000007 and see if you get this number. Probability of not dying is the same thing as probability of 1 minus probability of dying. So probability of not dying is the same thing as 1 minus probability of dying. And that's the definition of complements. 1 minus probability of dying is the same thing as probability of not dying. You could do it this way, or you could say 1 minus probability of dying was 0.00007, which is at the end, our answers would be the same. Any question? And that happens very, very rare that someone dies. So the chance of not dying is pretty high. Okay. So now I want you to look at this page. Just using probability to determine something is significantly low or high. So look at this one for a minute. Okay, so using probabilities to determine whether the results are significantly high or significantly low. So probability of event, if it's less than 5% or less than 0.05, we call it unlikely. So in this case, dying 0.000007 is definitely less than 0.05. So then you would say it's unlikely to happen because it's less than 5%. We use that 5% rule multiple times in this course. Okay. So here is the key of this section. I allow you to copy it down for a minute and then we'll move to 4.2. Okay. Something that is impossible has a probability of 0. Something that is certain has a probability of 1. Something that we would say probability of an event A is P of A. And we show complement, probability of A not occurring with A bar. So now, let's go. This was the main ideas of this section. Okay. Now let's go to 4.2. And I put 2 videos that these may help you to understand the concept better as well. So I highly suggest that you watch them before attempting homework. Again, as part of 2 hours a day that you need to spend outside class, outside the lecture. Okay, 4.2. Addition rule, multiplication rule. Okay, addition rule is a probability of one event or another event. Means either event A occurs or event B occurs, or both occurs if that's possible. And then the word or makes it to be addition probabilities. So or associating with addition rule. And then multiplication rule is associated with and, means both happening at the same time. Probability of boy and girl. And that's multiplication rule is associated with and. So then multiplication rule is multiplication of possibilities. Again, happening at the same time. So, or associated with adding and associated with multiplying. So please write these 2 as in your notes as we're going to use them in the problems. And now multiplication. Just knowing the association of and multiplication or an addition. Okay, compound events. Compound events is the event of combining 2 or more simple events. So when there are components to a simple event. So for example, the event of 2 girls And a boy is a compound event because could be girl, girl, boy, girl, boy, girl, or boy and then two girls. So there are combination of 3 events to be compound. So again, compound event. An example of compound event is probability or event of 2 boys and a girl. And that is boy, boy, girl, boy, girl, boy, and then girl, boy, boy. So boy, boy, girl, girl, boy, and then girl, boy, boy. So each of these are simple events, but then 2 boys and a girl is a compound event because it's combination of these 3. So you need to know the names, but at the end, we're gonna do problems. Comprehending the situation. Notation of addition rule is P of A or B. So probability of A or B is event A happening or B happening, but counting the things that have overlap only once. So that means you say probability of A happening, probability of B happening, minus probability of both happening at the same time. So please write that out because you're gonna be counting it twice, so we need to take it out once. So probability of A plus probability of B minus probability of both happening at the same time. Okay. Probability of A or B is adding probability of A to probability of B, subtracting probability of them both happening at the same time. So please copy it. Okay. Now talking about disjoint events. So please write these definitions because you may get confused with vocabulary at the end. So as I give you time, please copy them in your notes. Disjoint events or mutually exclusive. Event A and B are disjoint or mutually exclusive if they cannot occur at the same time. Event A and B are disjoint if they don't happen at the same time. They cannot happen at the same time. So if you are rolling a dice once, not at the same time, you can roll 1 and 2 together if you are doing it once. So event of rolling 1 is disjoint from rolling 2. Yes. Not 1 and 2 can happen at the same time. Event of rolling head or tail, head and tail. So basically not head and tail can be rolled at the same time or tossed at the same time. So then that's disjoint. Any question? Was there any question here?
So basically, I'm saying it's just like one event that can happen, or like
Yeah.
tails can happen at the same time as heads, or so on and so forth.
Your head and tail are not happening at the same time. But I could say probability of today raining, or my friend has a baby girl. So they can happen at the same time. They can happen at the same time. So things that cannot happen at the same time are disjoint. Okay, let's look at example. Randomly selecting someone for a clinical trial who is a male. Randomly selecting someone for a clinical trial who is a female. So that's one selected person cannot be both. So they are disjoint. So not that thing cannot happen at the same time. But if you have, let's say you have colored balls in a hat, and you are tossing a coin at the same time, drawing a blue ball and tossing head. So if you're doing them at the same time, both can happen at the same time. But then drawing one ball and that be both yellow and red at the same time, it's not possible. Okay. So now here's the summary. Have the formula. We're going to go to some questions of probability A or B. And then addition rule associated with that. So we need to take away their points of intersection, which we're going to practice it with problems. We're going to practice that problem. Okay, for complementary events, just remember that probability of A and its complement is 1. That's the same thing we practiced in the previous one, probability of dying and not dying at the same time. I mean, it's 1 because either they will die, which is 0.00007, and not die, which is 0.99993, together is 1. So either you can say probability of complement is 1 minus probability of A. If you remember, we said probability of not dying is 1 minus probability of dying. So all three of them is the same thing. Means probability of dying and not dying is 1. So please write that out. Okay, here it is. Yeah, all of them are the same thing. Okay, now I want you to read this question and then find the probability of someone who has not sleepwalked. So read this one and see if you can come up with an answer and then send a chat to me. So please send me the answers. What do you think would be the answer here? So this is gonna be, they gave you the probability of a sleepwalked. Now what would be the probability of not a sleepwalked? Yes, so many of you answered right. 1 minus the sleepwalked is probability of not a sleepwalking. So that's 0.708. Okay. Probability of event A and B. We show it by P of A and B. And then look at this notation here. The next one is probability of probability of B given, this line is given. So that probability of A happened. So let's just review this. Probability of B given A happened. Probability of B given A happened. So maybe write these two notations because we're going to use them very often as well. Again, more of notation and we're going to get to some problems. Okay, probability of A and B. Probability of A occurs in the first trial and B occurs in the second trial. And probability of event B given that event A happened already. Okay. So for the AND, we said it's the same thing as multiplication. So in many cases, it's probability of A. So let me just write it. So it's two trials. So when you are saying probability of A and B is the same thing as probability of A times probability of B, assuming that event A already happened. So it's probability of A, assuming that, so probability of, so let's do it this way. So probability of A and B is probability of A times probability of B, assuming that A already happened. So we're going to use that in examples again when we get to examples. So here is an example. Let me just make it big. Let's say oh, sorry, the next one actually is, the next one is going to be the example. So let's just have independent events. Two events are independent. If pulling one or happening, the chance of one happening is not affecting the chance of the other one happening. So two events are independent if occurrence of one does not affect the probability of occurrence of the other. So these two are going to be independent. They are dependent if they are possible to probability of one affecting the probability of the other one, if that makes sense. So an example to that is probably, let's say you have a bowl with two cards. One is yellow, one is red, one is green, one is blue. And then you say the probability that I draw one card that is yellow, I don't replace it, and then I get red on the second one. So probability of red on the second one. Since you already took this out, then the second one is dependent because you don't have yellow in the pool anymore. So two events. So let's say, I'm going to write this example that I told you. Let's say there are a total of 4 cards. That's yellow, red, blue, and green. So probability of drawing yellow and red without replacement. So probability of yellow is 1 out of 4. So that's easy. So it's 1 out of 4 times, then probability of, it says without replacement, means you're assuming that the first one happened. So you assume that yellow is in your hand. Now the probability of red would be, so yellow is in your hand, you assume yellow is in your hand. So it's 1 out of 3. And then you multiply. So basically, probability without replacement is an example of dependent. Because probability, if you were just drawing red from the beginning, would have been 1/4. But now since you have yellow drawn already, then it's 1/3. Okay. Let's just do another example. 50 test results from subjects who use drugs are shown below. 45 positive and 5 negative. It's a total of 50. So let's just, so write down this one, positive test results, 45, negative test results, 5. So write that out. So now let's read the question. If 2 of these 50 subjects are randomly selected with replacement, means you take one and then you put it back in the pool. Then find the probability that the first selected person has a positive test result and the second person has a negative test result. So it's with replacement, so they are independent of each other. They are not dependent because you're putting it back in the pool. So you first drawn one person. What is the possibility that that person has a positive test result? Let's answer the first question first. First part first. So send a chat to me that just for the first part, 45 positive results, 5 negative results, total of 50. What are the chances that you draw the first person and that has a positive test result? So positive test result. What are the chances? If 45 out of 50 is positive test result. I don't know why my computer is not. Oh, give me a second. Sorry, I got disconnected. For some reason, my computer was not functioning. I don't know if you heard me. But let's just continue on what we were doing. Let's just go back to Canvas. There are times that I really like to make it a lot more interesting. It's gonna get interesting when you're talking about probability, but again, it's very subjective toward finding probability of different events, that some of them may not be the point of your interest to even find a probability. So I get that point, but please follow along. Oops. Let's go to 4.2. I don't know if you were sending me chats about the probability of the first event. Okay. So here we have the example. So probability of positive test results is 40 out of 50. So that's the first one. It says with replacement. So that means no matter what you got on the first one, you're gonna put it back and you're gonna draw another one. This time it says probability of negative test result. So the question was, if you remember, said probability of, find the probability that first selected person has a positive test result and second selected person has a negative test result. So positive and negative. positive and negative. So positive test result, 45 out of 50. Negative test result, 5 out of 50. So then, and it says and in here, if you see. So and means multiplication. So you multiply them together to find the probability of that. So you remember we said and is multiplication. So first, positive test result, and second, negative test result, again with replacement. Now let's look at the second part. It says 2 subjects are selected without replacement. So that means 1 positive and 1 negative, but this time, or what is a negative test result or positive test result? Repeat part A. Oh yeah, you're repeating part A. So you would say drawing 1 positive test result and then the next one to be negative test result, but without replacement. So positive test result is good. So 45 out of 50. So you take it and then you don't replace it. You assume that the first one happened. So you have 1 item in hand. And that item you have in hand is a positive test result. So then your total, if 1 positive test result is in your hand already, it would be 45 remaining positive and 5 negative. So total is 49. So this time is 5 out of 49. So then the result would be 45 out of 50. And then assuming, since it's without replacement, assuming that one of the positive test results is out and in your hand, so you have 49 in the pool remaining. So it's 5 negative out of 49. So that's the difference between with replacement and without replacement. So without replacement, you assume that it's in your hand already. So sampling with replacements are independent, without replacement cost dependent. Because when you draw one, then the pool would be less items in that. Okay. So let's just do another problem. It says, so read this question. It says, without replacement, so independent events, out of a large population, 10% of adults in the US use drugs. So find the probability that 3 selected adults all use drugs. Means the first one uses drugs, the second one uses drug, and the third one uses drugs. So it's and. So it's 10% times 10% times 10%. Because and means multiplication is without replacement. Although it's without replacement, but since it's a very large population, we don't, even if you take 1 out of that large pool, it's not going to really affect this one. So 10% times 10% times 10%. So it's 0.1 times 0.1 times 0.1. So 3 using drug back to back. Okay. So now let's do some examples from, let's do this one. So read the question. And do this. So I'm going to give you a minute. Read this. Do you have any idea for the first one? It's very simple complement. So you know the probability of failure. What is the probability that you randomly select one and that would work? Just send me the result on the chat for part A. So please have your calculator handy. Again, our conversation here would help us to go on track. Very good. Very good. I'm getting results. So please keep going. So the probability of failing or failure is 0.002. So the probability of working is 1 minus the probability of failure. So it's 1 minus 0.002. So many of you got it right, 0.998. Then it says, given that the Airbus 310 actually has 3 independent hydraulic system, what is the probability that on a typical flight, control can be maintained with a working hydraulic system? So let's say in 3 different flights. So that would be the first one working and the second one working and the third one working. So the word and means multiplication. So you could multiply. So you could multiply 0.9998, 0.9998 multiply to each other, or multiply the failure 3 times and subtract from 1. For either of the two, you should get the same answer. So it's multiplication of all 3. Either you multiply all failure and subtract from 1, or working 0.998, 0.998, 0.998. Any question?
So you would add for like the 0.998. If you were using that instead, you just add the 3.
You don't add them. So it says and multiplication of the first one working.
Oh yeah,
and the second
multiply.
one.
Not multiply. Yeah. Thank you.
Then you get the same result. Okay. So that's about, and then for addition rule, if we had or, we would have add. So let's just do one example with or as well. Let's go to the textbook and pick an example with or. We did multiply of them with and, but let's go and do some with or. And let's pick some from the worksheet, in fact. Let's go to the worksheet of chapter 4, modules. Always worksheets are toward the end. It's a PDF. Okay, let's do some of these. That's the main idea of what we need to learn in this chapter, basically. So I'm going to ask you questions and you tell me what is the answer. So let's look at number 1. It's just not or and, it's and. It says the following table, and it's sometimes easier to look at the table. Look at the table and then answer the question. If one flight is selected, what is the probability that that is on time and upstate airline at the same time? So upstate airline and on time. So you look at their overlap. So you would say, what is the probability of that happening at the same time? And so it's 43 out of 76. So I assume that they add up. Oh, hold on. Let's see. What is add up? Do you find the total of all flights? Because it says, so 33, 43, 6, and 5 together. I think that's 87. So you would say 43 out of 87, because you are randomly selecting from everything. Then that's 43 out of 87. So that's the answer. Let's look at another one. Yeah, you add them all because that's the total number of, what does this one tells you? That Padunk airline and upstate airline, they have 33 flight that is on time and 43 that is on time and 6 that is late and 5 that is late. So what are the total number of flights? 87. So our favor is being on time and upstate. So that's 43 out of 87. So look at here, look at number 3 and see if you can answer A, B, C, or D. So number 3, refer to the table which summarizes the result of testing. If one of the results are randomly selected, what is the probability that is a false negative? False negative. False negative means someone do not have the disease, or false negative means the person has the disease and the result comes negative. So that's 4 out of the total. So that would be 4 divided by the total number of possible cases. 111 plus 4 plus 11 plus 172. What is that together?
298.
298. So I trust your calculation. So then what is 4 divided by 298? I think that's about 0.01
34.
34. Sorry. Okay. The probability of the error is low and the test is fairly accurate. So since the probability of false if the probability of false negative and positive is low, that means the test is pretty trustable. I mean, you cannot get any test that is 100% valid. So if they are doing any drug test or any disease test and then false negative or false positive has a low probability, then that test is trustable. Okay, any questions? So number 4, you flip a coin twice. What are the possibilities? So you get a head, head, tail, tail, head, tail, tail, head. So you're flipping the coin twice. Create a sample space of all possibilities. Which one is the answer? Got A, B, C, D. Send me what do you think is the answer? So if you answered B is correct, but if you said D, tail, tail, and head, head, head is not on D. So it's not correct. So, but head, 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 tail, tail, head, and tail, tail are the possible. So many of you said B, that is correct. Okay.
I'm only a little confused because it says flip a coin twice. So maybe I'm not understanding.
Yeah, because but it's the same. Like you flip it once. It could have say flip 2 coins at the same time. That's the same thing.
Okay. Okay.
Yeah, flipping it twice means once you flip it, that's head. Again, could be head. You can, if it's head the first one, it could be tail on the second one. You can flip the tail and then the second one to be head, or if you flip the tail, the second one could be tail. So
I see. Thank you.
the same thing as if you were flipping 2 coins. Sample space means all possibilities. Yes. Okay.
So it would be D for that one, right?
B for that one. B as in boy. I said D is not because D doesn't have head, head, and doesn't have tail, tail.
Right, got it.
So B is next. Okay. So let's do one more. Let's do number 14. That's part of 4.3, which we're gonna go over in a little bit. So it says this is the test table for the testing. A test subject is randomly selected and tested for disease. What is the probability that subject has disease given that the test result is negative? The word given makes it conditional. So saying that the person has a positive test result, so it's either of the two, given that the test result is negative. So it says, has the disease, given the test result is negative. So test results negative, so it means you went to the place and you got your test results negative. So that's the given situation, given that the test results were negative. So you just put your focus after given, whatever is the population or whatever is the event, you put your focus on that because it says the word given, test positive, test negative. So that's this one. What is the probability that subject has disease? So 9 out of, so you just don't look at the whole total, just the total of test results negative because that's after given. So given that population that has a test result negative, what is the probability that has disease? So it's 9 So it's 9 out of 321. So then 9 out of, 9 out of 312. So 9 out of, oh, you're adding them, sorry. So the total, 321, that's right. 9 out of 9 out of 321, 0.028. A is the result. A is the answer, right? So when it says given, you put your focus on the group that is after given, not everyone. For and or, you look at the total everywhere. Okay. So I let you look at the rest of the worksheet on your own. There are 20 questions. Do them, and then if you need help on any of them tomorrow, let me know. On every worksheet, I tell you which one to look at. So number 10 and 16 are ignored on this worksheet. Okay, let's go to 4.3. I also put 2 videos here for more clarity with all 3 sections. Please watch the videos after class. So we're going to talk about conditional probability in this section. And conditional was the word given. So we extend the multiplication rule to include probability amongst of our trials. We get at least one of some events. So saying at least one head when you are flipping coins twice. And then also we're going to talk about conditional probability, these 2 items. At least one means one or more. If I say at least one, I drink at least one coffee per day, that means one coffee or more, 1, 2, 3 and more. Complement of getting at least one, what is, if I say I drink 1 cup of coffee per day, at least 1 cup of coffee per day, that's 1, 2, 3, 4, at least 1. What is the complement to that? I drink no coffee. So complement to at least 1 is no. I hope that's just a common sense that you understand. Okay. So of course, that's the same thing, so we don't need to explain it again, but at least one occurring is the same thing as 1 minus the complement, no occurring. That's the same thing as P of A is 1 minus P of A bar. Okay, so let's read this one and see if you can come up with the solution. Send me the solution via chat if that makes sense. I give you a minute. Okay, let's look at this one. It says a study found that 6% of damaged iPads were damaged by bags or backpacks. If 20 damaged iPads are randomly selected, find the probability that at least one was damaged in a bag or backpack. So at least one means one was damaged, or two was damaged, or three was damaged, or four was damaged, and so forth. Or you could say 1 minus probability of no damage out of these 20. So that means the first one is not damaged, the second one is not damaged, the third one is not damaged, none of them is damaged. So probability of at least one damaged means is the same thing as 1 minus probability of none is damaged. So first one not damaged, second one not damaged, and so forth. What is, if 6% is a probability of damaged, what is the probability of not damaged for one of them? 0.94. Do you agree? 0.06. 1 minus 0.06 is 0.94. So it's 0.94 times 0.94 times 0.94 because you are saying all 20 of them not damaged. So basically, probability of at least one damage is 1 minus probability of non-damage. So you would say 0.94, the first one not damaged, the second one not damaged, the third one not damaged, fourth one not, 20 of them. So it's 0.94 to power 20. It's that none of the 20s are damaged. So 1 minus non-damaged is at least one damaged. So I know logic might be, so 0.94 is probability of one not damaged. So we want to know all 20 of them not being damaged. So it means the first one not damaged, the second one not damaged, the third one not, the fourth one, so forth. And we are saying and because we want none of them to be damaged. So that means multiplication between all the damages. So this would be probability of none being damaged. So there's a 29% chance, or 0.29, that you get 20 iPads and none of them are damaged. So the probability of at least one damage is 1 minus no damaged. So that's 0.71. Some of them needs more review and comprehension. The logics might be difficult. So go back, please go back and review them if you want to do well on the test. Okay. And here's the conditional probability of an event is probability obtained with the additional information that some other events has happened. So conditional, they put condition into the probability. Probability of B given A. So probability of B assuming that A happened. That's why when we said like we go only to test negatives, because assume that they said only test negatives. So this reads as probability of B given A happened. So the conditional probability of B occurring given A occurred. So that means assuming event A occurred, and then you calculate event B. So probability of event B given A is a probability of A and B happening divided by probability of A. So this is the same thing as you remember, like in the last one, we had, let me type here. We had probability of A and B is equal to P of A times P of B given A, be given, I don't know how to put that line with my laptop, given A. So look at here. So we had this one earlier. Probability of A and B means probability of A times probability of B given A occurs. So now they are isolating B given A by dividing both sides by P of A. That's why they brought this P of A to the denominator here. So conditional probability, you go to the table, you look at the, assuming that event A happened, and you find the probability of B. So here is an example. So please read the scenario. There are 555 tests. Find the probability that the subject has a positive test result given that the subject actually uses drug. Positive test result given that that person is actually using drug. So what do you think is going to be the probability? The probability of positive test result given that the person uses drug. So you go to uses drug, subject uses drug, it's here. You're finding positive test result out of, we said whatever is after given, you go to that population. Given that it's coming from this population, given that that person uses drugs, so it's either of these 50 people. Actually, positive test result is 45 out of 50. So then it's 45 out of 50. So positive test result, and you look at the total of those who use drug. So you use the total basically from the things coming after given. Okay. So you can always just look at the table and come up with those results. So there is another one. It says we are dealing with 70 subjects in the first column of the table. Find the subject uses drug given positive test result. So in this case, the next question is given positive test result. So you go to this total. Whatever comes out of after given, you go to that first. So that's 70. Given positive test result, subject uses drug, I think they said. So it's 45 out of 70. So positive test result, there are 70 of them that are positive test result, and 45 of them are those who are using the drug. So that's why. Okay. So what I want you to do for tonight is I want you to do the worksheet. So watch the videos. Here we go. So let's do this in order. And again, the summer course is moving very quickly. Things are happening very quickly. That's why, like, things that we are covered in 1 week of summer school, we cover in 3 weeks of regular school. So that's why it's faster. So what I want you to do is for module 4, I want you to go to 4.1, 4.2, and 4.3. So go to these 3 sections. Watch the videos I put. That may help you to understand things better. Forget about the questions. These are all optional. Then I want you to go to the modules worksheet for chapter 4 and complete that by tonight. When you come to class tomorrow, maybe I ask you the first 10 minutes if you have any question out of that worksheet. If you don't follow the watching video and doing the worksheet today, you may not understand this one. Again, I do my best to go as slow as possible, but there are things that are absolutely out of my hand. I need to cover these materials, but I really ask you to watch the videos. Again, we are meeting half the time we should in a regular summer course. Because of pandemic, department decided on 50%. The other 50% would be just watching the videos I put and then doing the assignment I assign. Yes, the worksheets are graded. Showing your work and putting the final answer, you get full credit and submitting them.